Hello everyone. For those who have not worked with me yet, my name is Joseph Crandall, and over the next 9 minutes I'm going to give you an overview of the type of work I completed this summer with the lessons learned. When I'm done, we'll have a minute for questions. Over the course of the summer, I've worked on 11 different projects as well as time spent doing training activities. I was able to see and work on a majority of the steps associated with a WeWork project from start to completion of sheets. And through that work, I spent a great deal of time working on floor plans and reflected ceiling plans. Along with this work, I helped to build a load calculation Excel sheet that can be used with exported Revit data to benchmark the accuracy of initial load. I completed my Bachelor's of Science at George Washington University in May of 2017 with a double major in computer science and physics. And I am still at GW currently working on my Master's in electrical engineering. Although I TA a course in the computer science department, my research is focused on optical computing, focused on improving energy efficiency and information density. I'm originally from Arlington, Virginia, and I assume there are a few additional NOVA citizens among us today. Finally, one thing that I greatly appreciated about working at ARUP this summer is my ability to bike to work, which is a vast improvement over the 45-minute bus commute one way that I experienced last summer. I was able to work with the majority of the electrical team throughout the summer, starting with our leader Layla and the Houston load calculation. Then I worked on a workflow efficiency project with Sarah that allowed the rest of the team to easily import electrical details. I spent the majority of my time on 1440 and 1201 WeWork projects, where I was working under Brandon and Julio respectively. Finally, I got to work on a small power upgrade project at my alma mater under Michael's supervision, and I was also able to help Greg on a small Excel job for the Smithsonian Air and Space bid. Additionally, I used the following tools over the course. The goal of the load calculation is to provide an estimate of the electrical load that a building will draw. The information is sent to a utility that will have to supply that load. This estimate allows the utility to prepare in advance for the increased capacity needed. We accomplished the load calculation by first taking the architectural plan for the Houston building and then create space types in Revit for the different areas within the building. We then exercise square footage schedule from Revit to Excel, where we can apply load multipliers to different spaces based on the National Electrical Code, as well as from past office experience. The table outlined in green is a sample from the exported space type Revit data. The Excel function in blue is an example of one of the Excel summations performed on the square footage based on the space types we are calculating for. The load for each floor type was calculated in Excel, with the B2 floor load coming out to approximately 175,000 volt amperes. The benefit of this system is that the same Excel load calculation sheets can be used on different Revit space type data given a predetermined number and definition of space types across projects. Given that this building has 2 floors below ground and 19 floors above ground, does anyone want to estimate the order of magnitude for the total load of the building? Our estimates have the total load for the building at approximately 2.3 million volt ampere. The problem that Sarah presented to me was that originally the Washington electrical folder had all the different details and that the electrical team uses in the single details.dwg AutoCAD file. Whenever we needed to use details, we would need to import the file into Revit and remove all of the excessive details. By adding each detail individually to the Washington Electrical Resource Kit Revit file, whenever one of these details is needed, you can import them individually into the Revit file that you are working on. For the WeWork 1440 project, my larger task was the development of the lighting sheets via the reflected ceiling plan. In this example, we will look at the components that comprise the ceiling plan. The daylight zone encompasses the 15 feet from the window's edge and allows for power savings during daylight hours through the use of the daylight sensors. The daylight sensor zone monitors the daylight sensor, which need to be placed at increments throughout the daylight zone for maximum energy savings. However, we can save costs by not providing full coverage by only covering unique daylight angles. The occupancy sensors shown allow for monitoring of motion and allow for energy efficiency when the offices are motionless and therefore assumed unused. Occupancy sensors have coverage zones where an optimization of energy efficiency to cost savings can be performed for this coverage in a manner similar to the daylight zones. All fixtures and sensors need to be circuited and properly labeled and grouped for panel schedules. The process needs to be done for the emergency fixtures as well, which require their own circuits and panels. For the power sheet view plans for 1201 Wilson, I will explain the southeast corner of the 26th floor as an example. All the workstations need 2 outlets requiring a set of 9 desks to have 4 quad receptacles and 2 duplex receptacles. A disconnect switch with full load amperage input is needed to power the mechanical air circulation and heating units. Keynotes are placed to give contractors specific and unique information concerning elements, in this case the use of AV equipment for certain receptacles. Callouts are used for complex areas in the floor plan that require more information for the dense space. The example shown is the callout for the pantry. All the elements need to be circuited and assigned to low voltage 120-208 and high voltage 277-480 panels and grouped so as not to exceed maximum panel amperages. The goal of the George Washington University Emergency Power Project is to provide increased resilient power for animal care and testing facilities that will persist if the rest of Ross Hall loses power. The goal is to route a 1600 amp busway composed of 5 6 to 4 inch conduits through the 3rd through 7th floor, but with the restriction that we cannot drill through the floor and instead have to use existing space and stairwells. I had to work in AutoCAD for this project because the original floor plans were in this format. In general, it feels like an older software that's not as easy to use as Revit, but has been a learning experience. Coming from an academic research environment, I can understand that it must be frustrating for a private sector company to interact with academia. Academic cash flow is a jerky ride with spikes in resources as grant money comes in and then is slowly allocated as the money dwindles. Hopefully, this is followed by an infusion of funds by another grant. However, Michael has indicated that this project is meant as a gateway to larger, more lucrative projects at GW with academia and healthcare in the DC region as a whole. Overall, it's been an interesting experience to interface with my alma mater from the outside. Throughout the summer, I learned how to use Revit for layout of power and lighting sheets, as well as for panel schedule design, electrical room design, and details importing and keynotes. I learned about Unify for importing components from ARUP's library, and Rushforth for exporting data sheets to Excel. I was taught how to estimate load calculations and why we perform them, and I watched and worked through the WeWork development process from a site visit at 1201 Wilson to submission of 100% completion of design development. Through my development of the load calculations, I learned how an individual at ARUP can learn, apply, and sometimes develop new tools during a single project or over multiple projects via the spreading of learning curves over multiple projects' cash flows. Most importantly, I did not do any of this alone, and I hope I can keep learning from all of the talented people ARUP has to offer. Thank you, and I will take questions at this time.